Hi everyone, my name is Mayra Tanke. I'm a senior generative AI data scientist at AWS, and today I'm here to talk with you about how to customize your generative AI applications for your business use cases using your own data. Okay, so in today's session, we will first discuss the approaches for customizing your generative AI solutions. Then we will have a very brief overview of what's Amazon Bedrock, followed by a deep dive session into retrieval augmented generation using Amazon Bedrock. And we will close this session talking about fine-tuning and continued pre-training using Amazon Bedrock. So before we start, why customizing? Why you want to have a very customized generative AI application? So there are many reasons to customize your generative AI applications. The first of all is that you want to have this application customized to your business needs. So you want this application to talk your business language. You want this application to be performant on your specific tasks and to really be context aware. So you want this application to have the most recent information possible so that you have the most recent data for your generative AI application. So like now just thinking about a legal application. So you want this application to talk legal terms, to understand your context, to understand what are the needs of this legal application, to be very good, for instance, analyzing your cases, and also to know the most recent cases. So you want to have all of this, and to have all of this, you need to customize your business application. So how do you customize your financial models to understand your use case? So when you want to customize your foundation models to understand your business applications, the key to this customization is your data. So your data is really the differentiator that you have here. And it's really the part that moves from a generic application to your business application. So it's what makes the pre-trained model your model. It makes the pre-trained model the model that solves your business tasks, your business use cases, and that talks your business domain. So how do we customize those models with your data? So there are several approaches to do this model customization with your data. So first of all, you can customize your foundation model without changing any weight in the background. So even without touching the model itself, you can customize this model by providing context to your prompts. And how can you provide this context to your prompts? So you can use knowledge bases to provide this context, or agents to provide this context. So when we are talking about knowledge bases, we are talking about semantic search. We are talking about vector stores. We are talking about embedding a lot of text information so that your model has this semantic similar information to update the prompt, to really augment this prompt with more static data. So when we are talking about knowledge bases, we are talking about documents, we are talking about FAQs, about documents, text documents that you would like to use to augment this data. So when we are giving this contextual information to the model using knowledge base, we are talking about some updates from time to time, but not really, really real time. If you need really, really real time, if you need more structured data that it's available on a database, on like via an API call, when we are talking about really dynamic data that you want to use to update your model, and we are talking about tasks that you want your model to execute so that you get a final response, we are talking about agents. So we are talking about having this agent that will execute the task of querying your database to get the most recent information that you need for your prompt, and will like return this response from the user to the database, for instance. But you can also customize your model by changing the model weights. When we are talking about changing those model weights, we are talking about really updating the model parameters so that you can get this model to really be trained with your data. So here we are talking about more historical information, and we want to update the model weights for your data. So there are two ways of doing that. So you can either fine-tune your model, and when you're fine-tuning your model, you're updating this model for a specific task. So when we are fine-tuning, we are talking about labeled data, and we are talking about improving the accuracy of your model for a specific task. So here we are providing the prompt and the response of this prompt. The data is usually smaller. You also need a smaller number of examples to get this model to perform well with your specific tasks. But then the other approach that we have to customize your model is about really adapting the model to your domain. So really learning your domain specific terms with a larger amount of data using continued pre-training. So with continued pre-training, we are talking about customizing your model with unlabeled data so that your model really understands your domain. So really understands your business and can answer questions about your business. So all of those approaches to customize your model, they are not exclusive. So now if you're doing continued pre-training, for instance, to understand your domain data, you can also then fine-tune your model to a specific task. So you can combine continued pre-training and fine-tuning. If you are now indexing a lot of data into a vector database and performing like semantic search, you can also augment this semantic search data with the most recent sales information of yesterday, for instance, by adding an API query that will get this most recent, more structured data with agents. So you can combine knowledge bases and agents. You can combine, for instance, continued pre-training with knowledge base by not now using the foundation model out of the box, but using your continued pre-training foundation model to answer questions about the data on your knowledge base. Okay, so how do I choose the technique to customize my model? And here I'm going to give you some prescriptive guidance of how to choose this technique. But again, we already mentioned those are not exclusive ways of customizing your data. So this is a prescriptive guidance of how to choose the techniques. But again, you can combine those techniques. Okay, but how do we choose? First, you need to start with the task. So what's the task that you want to solve and which kind of data does this task need? So does this task need external data? Does it need up-to-date information? Does it need data that the model does not know? Does it need information that the model was not trained with? If that's the case, then you need to think about the frequency of this data. Is it real-time data or is it more static information that you need? So if you need more statical information, you can use knowledge bases. So you can use this semantic search from vector stores to search on documents, on FAQs, on wiki pages. So anything that you created embeddings and indexed in a vector database. And I will come to those terms pretty soon. Okay, but what if you have the need of more real-time data? So if you need dynamic information, really real-time data, something from a database, something a bit more structured, you can use agents to augment your foundation model and to perform tasks. So you can use agents, for instance, to query your database, get the sales from yesterday, get the forecast for next week, for instance, so that you can get all this information from a database and augment your prompts. Okay, but what about when your task requires more historical information? So when you want to use more consolidated historical information, then you need to think about your task. Is it a simple task? Do you have everything you need for performing this task already available? For instance, if you want to summarize text that you're providing to the model, the model already knows how to summarize that. So if that's the case, if it's a very simple or generic task that you need to do with your model, all you need to do or you have to do is to use prompt engineering to formulate the question, to formulate the request in a way that your model will understand. And then you can use the out-of-the-box model to give you the information necessary. And then if you're talking about a more complex task, something a bit more difficult, something more specific, then you can customize this model, either using fine-tuning or continued pre-training. And you can use this more complex or specific tasks. You can solve those using customized models. So when we're talking about customizing models, we're talking about changing the weight of your model. Okay, so now let's have a very overview of Amazon Bedrock. What's Amazon Bedrock and why is it necessary for my genAI applications? So Amazon Bedrock is the easiest way to build and scale your generative AI applications with foundation models. So what Amazon Bedrock provides you is a large choice of foundation models, both from Amazon and third parties, that can be used for different tasks. So you can have models for text use cases such as summarization, as chatbots, and so on. Or you can have more image-related models to generate images, to search on images, and to get those image use cases. And then you can select this model and you can either use as it is, if the model is already doing what you need to do by just creating your right prompt. So by doing prompt engineering, you can use the model as it is to solve your business case. Or if you need a bit more specific case, then you can customize this model with your data and give the right context to this model. And then once you have the right context, you can send this prompt to your model and you get the response. And then you can use API queries to get this response and to use this response on your application. All of this with the security, privacy, and responsible AI that you already need, provided by AWS. So all of this is fully managed by AWS. Okay, so now let's dive a bit deeper into retrieval augmented generation so that we can understand how to customize our models with Amazon Bedrock. So first of all, what's retrieval augmented generation? As the name indicates, retrieval augmented generation involves retrieving the relevant content for your prompt so that you can augment this prompt and you can generate the response. But now you ask me, why do I need to do that? Why can't I just pass all the information I have to these models? Those models are pretty big. They are used to all this information. So why can't I just pass all this information to this model? So two main reasons for that. First of all, those models, they work with something called content length. So this content length determines how much information you can pass to this model. And this content length can be pretty big, but if you're passing too many information, you might not be able to do so because your model might not have enough content length to receive this information. And then what you get is just an error. Or let's just say you have a pretty big content length and you can pass all this information. Then you're giving all this information to the model. So now let's just think what happens with us when we get all this information. Let's just say you now have to answer a question and you got like 5 different books to answer this question. So what do you do to answer this question? So first of all, what we or the model does is like first try to determine what's important to answer this question. So we need to really find the relevant information to answer this question. And then you can answer this question. So this all takes time, right? So you first need to find what's the right information to then answer the question. So all of this is adding time to your model. So it's increasing the response time, increasing the latency of your model, and it makes it slower. So if you're passing all this information, your model also becomes slower. So that's why you need to have a RAG. So that's why you need to first retrieve the relevant information to then augment your prompt and generate the answers. Because you want your model to, first of all, succeed. You want the model to be useful to your task, but then you also want it to be fast. So you need to retrieve only the relevant information. Okay. And what are the use cases of RAG? So why do I need to do RAG for my foundation models? So the first use case, the most important use case that we have for RAG is to really improve the content quality. So we want to answer right. So we want to have the right answers for your prompts. So you want to reduce the hallucination. So what happens is that those models are pretty big. And when you're asking a question and the model doesn't have the information to reply this question, maybe it's a true new information, sometimes is that the model will try to infer the answer and will give you an answer that is just wrong. So here the model is hallucinating. So you can imagine that the model is trying to be very helpful and it's giving you an answer that it's wrong. So it is providing you a low quality response. So the main reason to use RAG is to really improve this quality and to reduce this hallucination so that the model only provides right answers. And then when we are going in this direction, we want to also have like contextual chatbots and question answering. So we want to have the chatbots that will only answer what it knows. So only based on the data it knows. So here is where you can use RAG to provide those large language models with the information that can be used to answer a question so that you can control much better what is used on the information for these models. So here is also the use case where you want to pass what were the references so that you can trust better the replies given by those models. Then you can also use RAG for more real-time applications. So like for more personalized search, you can pass your whole profile to this model, and for more real-time data summarization, for instance. So everything that requires more recent information, you can use RAG for that. So first of all, RAG is not done only using knowledge bases or only using agents. You can use RAG for both of them. But one very common way of doing retrieval augmented generation is via semantic search. So what semantic search does, it searches from a vector store what is the most similar like documents or text based on the meaning that you have. So from the semantic search, you want to get the closest meaning document so that you can answer your question. So like one way of doing RAG is to implement semantic search so that you can get this closest meaning documents from that. So for doing semantic search, a very important concept that we have are embeddings. So now that we know why embeddings are important, which kind of embeddings are available in Amazon Bedrock? And here I'm going to talk about text embeddings because we also have a multimodal embedding with Titan, but I won't dive deeper into these ones today. So talking about text embedding, on Amazon Bedrock, we provide you with Titan text embedding models. So the Titan text embedding allows you to embed text of up to 8,000 tokens into this 1,536 vectors of numbers. So it's like 1,536 numbers that you get on these embedding vectors. And those texts can be on 25 different languages. So with that, you can retrieve the documents for like search use cases, for similarities, for clustering those documents, and you can apply those embeddings to like semantic search, to personalization, and so on. We also offer two Cohere embedding models on Amazon Bedrock. We offer the Cohere embedding models for English and the Cohere embedding models for multilingual use cases. So they're pretty similar, so you can embed up to 512 tokens into this 1024 numbers vector. And the difference between them is that the English embedding has been trained with English only text, while the multimodal embeddings has been trained with more than 100 supported languages. And yeah, you want to use the English one, especially if your application only has English text, because then it will work a bit better for English. Okay, so how does a RAG application works for this semantic search? So what we have is the user input, and we want to have this response from the large language model. So for doing that, we want to augment our prompt with this most recent information. And yeah, we want to pass this prompt to the model to get this reply. But how does this workflow work? So first of all, we need to have the data injection workflow. So we need to have all of our data and our documents, and we need to create a document store, a vector store of those documents by creating embeddings of chunks of those documents. And we are going to discuss chunks really soon, but you don't want to embed your full document into your vector store, but you want to embed parts of it so that when you're searching, you're not going to return a whole book, but only like the pieces of the book that you need, so only the important information. And then when the user is asking a question, what you do is you're embedding the question of the user, and then you're comparing this vector that you created with all the vectors available on your vector store using some kind of distance of those vectors. So a very common one is similarity between those vectors. And then you find the closest ones, and you return those closest ones to your context. And then you use this context on your prompt to give you the reply. So even explaining that is complicated. So when we're talking about RAG, you can see that this has many challenges. So we are talking about multiple data sources. We are talking about creating this embedding vectors for large volumes of data. We are talking about incremental updates on your vector store every time you have a new document, or maybe you deleted a document from your vector store and you don't want it to be on the vector store anymore. So all of this requires a lot of code effort. It requires a scaling mechanism. It requires a orchestration mechanism. So there are some open source techniques such as LangChain that already makes this much easier. But you still have to write a lot of code. You still need to understand the concepts. You still need to think about versions. So to make it all easier for you and to make it all managed for you and much simpler to implement, what Amazon Bedrock provides is the knowledge bases for Amazon Bedrock, which is a secure way of creating those vector databases so that you can augment your prompt and you can have better results on your RAG use cases. And all of this with built-in session context, so like you can get your historical information for conversations, and you have the automated citation. So how does this RAG workflow works? So you have the data injection workflow, and you are gonna have all your data sources, and like for these data sources, you're gonna create the chunks and you're gonna embed those chunks to create your vector store. So with knowledge base, you can like add any document to your data source. You can have different types of documents and everything in your data source, and this is all automatically handled for you. And when we are talking about the chunks, you can choose your chunk strategy so that your document is split according to the strategy that you would like to use, and it's all implemented for you. And then you just have to choose an embedding model and to choose the vector store that you want to use for this. So when we are talking about the workflow we had before, now you don't need your data injection workflow anymore because this is all managed by AWS for you. But let's just say that now you don't want to have to manage the part of like creating the embedding from the user query and then generating an output with this augmented prompt. So you want everything to be out of the box. What knowledge base provide is this retrieve and generated API that will do everything for you. So you pass the user query to the retrieve and generate API. This API will generate the vector embeddings and will pass the answer to your model. And this model will then create the response that it's passed back to the user. But now you want to have this control. So you would like to be able to control like the foundation model you're using. Maybe you want to use one of your fine-tuned models. Maybe you want to, like use another model that it's still not available on Bedrock. So what you can do is you can use the retrieve API so that now you pass the user input. You don't need to create the embeddings for that. It's all handled by the retrieve API, but you only get back the citations that you can use on the context of the prompt, and then you handle the prompt itself. Okay, so at the moment, knowledge bases for Amazon Bedrock support 4 different types of vector databases: the Amazon OpenSearch Serverless, the Amazon Aurora, Redis Enterprise Cloud, and Pinecone. And the support for MongoDB is coming pretty soon. Okay, now let's talk about agents. So all of this was talking about semantic search, so indexing documents and everything. So now you want to take actions, you want to connect to your database, you want to get the most dynamic information possible. So for that, what we have is agents for Bedrock. So you can, with agents for Bedrock, you can select your foundation model, you provide some instructions to this agent, and this agent can then connect to the relevant data sources and can take some actions, and all of this is orchestrated for you. So the benefits of it is that you have all this automated orchestration and multi-step approach, and you can build and deploy your applications with agents. And you can also choose the language, implementation language that you're using, and all of it is managed for you. So it's all a managed solution, and of course, secure with the AWS standards. So now that we discussed knowledge bases and agents, how can you update the model weights? So how can you really change the model weights so that you can customize your model? So here we are talking about fine-tuning and continued pre-training. Amazon Bedrock provide custom models that allow you to increase the accuracy of your foundation model by providing either labeled data for fine-tuning or unlabeled data for continued pre-training. And once those models are deployed, you can invoke them the same way that you would do with the pre-trained models using either the playground or the API queries. And you can do that for fine-tuning with the Titan models and third parties, and for continued pre-training with third parties. So just looking at the model supported, Amazon Titan models are supportable for fine-tuning and continued pre-training, while fine-tuning also supports additional models such as Cohere, Meta, the Titan ones, and coming soon Anthropic models. Okay, and how do you choose between fine-tuning and continued pre-training? So for fine-tuning, we are talking about task-specific, we are talking about labeled data. We want to provide instructions to your model. So you want to provide this labeled data. So to choose between fine-tuning and continued pre-training, you have to think about the question, do you have this instruction data available? What's the task you want to solve? Do you want to customize to a specific style, to a behavior, and so on? While for continued pre-training, we are talking about raw data. So if you have all these PDF documents, larger data sets, and everything available, and you want to customize this model for the domain adaptation. As we already mentioned today, you can also combine those two techniques with continued pre-training and fine-tuning if you want to adapt for your domain and for a specific task. Taking a look at the data sets required for those different models, you can use instruction data sets, so like labeled data for fine-tuning and raw data for continued pre-training. So just looking at how the data format works, so you pass the prompt and the response on fine-tuning, while just the input for continued pre-training. And a good call out here is that the fine-tuning data is usually smaller, so you're passing your prompt with the response, it's a couple of paragraphs, while the continued pre-training data is usually pretty big, so you're passing full chapters of a book or the whole book as your inputs here. Okay, what are the customization components of your model customization? What are the components of your model customization job? So you have your inputs, which is the base foundation model that you're going to customize, the hyperparameters that you are going to use for this customization job. Here we are talking about batch sizes, we are talking about the number of steps, the learning rate that you need for this customization jobs, and you have your input data in the formats we just mentioned. Then you run this customization job and you will get as output both the output model, but also the metrics and logs of this output job. So when we are talking about the output model, we need to store it for you. So with Amazon Bedrock customization jobs, both fine-tuning and continued pre-training, Amazon is taking care of storing this model in an Amazon managed account with the full security components that are necessary for it. But this model is managed for you. And then for the inference, this model behaves as any of your pre-trained models. So you can do inference on the playground or via an API query. Looking at the architecture of it, when you have your training job, what you get is a copy of your existing foundation model, and you will pass the data to like fine-tune those weights so that you change the weights of your job, and then you're going to store your fine-tuned model. So the fine-tuned model, the pre-trained models, they are all on an AWS owned and operated account. They're all managed for you, while your data is only on your account and it's accessed using virtual private cloud or VPC with all the security standards. Customized jobs also require you to provision the capacity for those models. So you need to do some provision throughput so that you can then run the inference as you would run with any pre-trained model on Amazon Bedrock. And of course, you have like the API endpoint, and you have the CloudTrail, CloudWatch, and IAM roles for doing the access control, the monitoring, and the logging. So looking from security and privacy perspective, your data is not used to improve any model, and it's not shared with any model provider. Your customer data remains only on your region, and we support both AWS Private Link and VPC configurations. All of this is integrated with AWS IAM, so you can create your IAM roles, and you can monitor and you can log and doing the metrics with AWS CloudTrail and Amazon CloudWatch. And everything is encrypted by default using KMS keys, but you can also provide your own customer managed key if you would like to have an extra security layer. So in summary, to end today, customizing your foundation model is a cost-effective way to improve your model accuracy. And Amazon Bedrock supports 4 ways of customizing your models: the knowledge bases, agents, fine-tune, and continued pre-training. And finally, again, you can combine those techniques to achieve better performance on your applications. So with all those techniques, you can get the best performance on your generative AI application on AWS. Thank you so much, and please don't forget to complete your survey.